Dave, thanks for coming on. Really appreciate you taking the time to have a conversation with me. Would you mind telling us a little bit about yourself before we get started?
All right. Well, my name's I'm known as allegedly Dave, and I've now for the last 18 years, and I've spent the last 9 years helping people for free.
Cool. Can you help me find like 10 supermodel girlfriends? I would appreciate that. That'd be great. So the topic today is...
Say that again. You started breaking up.
I was asking if you could help me find 10 supermodel girlfriends for free. That would be great. That would be awesome. But so the topic today was evidence of flat Earth. What is your position on flat Earth?
Oh, my position on flat Earth. Well, the Earth is flat. Simple as that.
Why do you think that?
Oh, for crying. I'm sorry. I might have to relocate because I think this this connection is really bad because you've frozen and I get like half of what you say.
All right, I can talk a little bit slower for you. Tell us the reasons why you think the world is flat.
Okay, well, as long as you can hear me, that's fine. The reasons I think the Earth is flat, the most obvious reason is the total lack of curvature. If the Earth is a ball, the circumference of 25 or 24,901 miles, then the very simple way of calculating how much curvature should hide, distant objects is 8 inches per mile squared. Yeah. So if you know the distance of something, you should be able to calculate how much of that thing should be hidden by the curve. Well, my first outing, the first thing I did when I, was confronted with the flat Earth was go out and check a lighthouse that was 12 miles off the beach. And according to the calculation, the first 32 feet should have been hidden. But I put my camera right down near the water, zoomed in on that lighthouse, and the bottom of the lighthouse where the water meets the rocks. So that actually right there debunks the whole idea that the Earth is curving. You can't have a flat surface on, especially with the sea, flat surface on a curved ball. And so I've been literally going around the world doing experiments, including one in Hungary on a place called Lake Balaton. And we basically set up a laser, shined it across the lake, and then went out on the lake in a speedboat, chasing the beam. And we got something like, I think it was 12 kilometers out, and the beam never moved. It should have been, again, about 30 foot high above our heads, but no, it wasn't.
Oh, I've done that experiment, and the laser does drop for some reason when we go onto a lake. But is it possible that if the curve...
sorry.
Go ahead. Is it possible that if the curve...
Again, you're coming out like a Dalek.
Sorry, is it possible that the curve is so big that small scale things like what you're doing can't see the curve? Because if the curve is really, really big, small scales wouldn't be able to detect it, right?
Well, no, because we've taken that into account. The fact that, and I did this on AutoCAD. I drew up the Earth to scale on AutoCAD, yeah, and tested this 8 inches per mile squared. So if over the course of 12 kilometers we measured no curvature, that must mean the Earth is much bigger than they say it is. To lose that much curvature, it must be a lot, much more massive than they're saying it is, and they can't account for that. So no, that argument doesn't work because we've mathematically calculated it.
We'll forget the calculations. Is it possible that it's bigger than what you think it is, and your calculations were wrong, and there's actually curvature, and you just didn't measure it? I think you just lost connection. Uh, so the per mile squared is like if you're on a curve, you're on a curve, and you measure 1 mile away, you've got a laser that's going straight across. The distance will be essentially 8 inches, but if you go 2 miles, because you're curving and continuing to walk down, it will be 8 miles squared, so that it'll keep you exponentially further down the laser height the further you go. So it's squared. And you're allowed. You testing. Can you hear us? Nope. Testing. Can you hear me now? Testing. Hey.
Gosh.
Hey.
Hello.
Hey, can you hear me? Testing.
Sorry about that. Yes, I can.
All right, cool.
Yes, I can. You got me now?
Yep.
Good. So where do we get to?
Oh, yeah. So I was asking about, could the curvature be larger than what you measured it to be, and you just didn't measure it? So even though what you measured seems to be flat, it's just because the curvature is a lot bigger than what you had expected.
No, because you can literally yourself go online, go to the Earth curve calculator, and do the experiments yourself. You know, find a landmark, preferably over the sea, because you know it's going to be flat. And you know, put in the figures into the Earth curve calculator, and you'll find it. You won't find the curve.
Well, I've done that and I found the curve, but I'm asking, just, is it possible that it's? Can you still hear me right? Oh, I think he froze again. Well, this is going to be a hard one.
Okay, now I'm back. This shouldn't happen again. Gosh, I asked you, where did you find the curve?
Oh, I find the curve in lots of places. They've done the tests in many different places. I've done the tests in many different places. But my question is like more general. Is it possible that the numbers that you find online are incorrect, and there really is a curve, and you just don't see it because it's bigger than what you've tested?
No, because as I said, I drew it up on AutoCAD, right, and a sphere the size of the Earth, and I literally tested the 8 inches per mile squared calculation, and it was roughly correct.
Again, so the question is those numbers could be wrong. Like the NASA numbers for what the Earth is could be wrong. They could be lying about those numbers, and it could really be curved, but you didn't measure the curve because it's bigger than what you measured. That is it possible?
So if that were possible, then all the distances between continents would have to change. It's a ball, remember. So if you make the distance between Ireland and America bigger, then the distance between America and China and Japan would be smaller. You know, it's can you see that? If it's a ball, then if you start moving the distances between continents, then everything gets thrown out.
I don't see anything getting thrown out. Why would that be a problem? Like the question is could we be on a ball and your personal measurements be not be able to see it? So you can't personally measure the distance between America and China.
So okay, so tell me what if everyone's wrong about the distances for things, what's the size of the Earth then?
I did have no idea, but that wasn't the question. The question is like you're assuming that the world is flat based off of your small measurements.
No, I'm
And
assuming the world is flat because, right, we've been told, right, from the beginning, apparently, that the Earth is a certain size, right, a certain radius, a certain diameter, certain circumference. Okay, we've been told that even before anyone was talking about the flat Earth in this time. So we've gone on ahead and tried to measure that. We can't find it. So now the only thing you can say is, well, perhaps the Earth's much bigger.
well, so here's the question: is if assume NASA is lying, they could be lying either way, right? They could be lying and say that the curve is smaller than it is, or they could be lying that there's any curve at all. But they
It's
could
not
be either
NASA
way
who's
is a
saying
lie.
this. It's not NASA who's saying this, is it? It's everyone.
It's everyone. Yes, like the
Yeah.
pilots and the planes and the
It's
ships.
everyone who's been told that, not just NASA, but everyone's been told
Right.
this is the size of the Earth. And if the Earth is spinning at 1,000 miles an hour, that's why we've got a 24-hour day.
Yeah,
So
yeah.
if the Earth is much bigger, so the Earth must be going a lot faster
Sure.
to account for a 24-hour day. Everything, if you change the size of the Earth, everything gets thrown out.
Yeah, but again, you've already thrown all of that out, remember? Because you're saying that you don't believe any of that stuff. So all that's wrong.
What I'm saying is it's not a ball, so it doesn't spin, right? And so if it doesn't spin, that's out of the window altogether.
Well, again, so my question is, are your measurements consistent with a very, very big round Earth? Would your
No.
measurements wait, how so?
Well, then tell me how big the Earth is.
I don't need to.
We'll recalculate it according to what value you give, and then we'll do the tests again, and we'll probably come up with the fact that it doesn't curve.
Yes, you would have to do that again because your data would be consistent with a very big round Earth, right? Because that's the question. Is the data
Then
that you
provide me with the size of the very big round Earth.
This is a
We'll
yes or
test
no
again.
question. This is a yes or
We'll
no
test
question.
again because we can only test on the data we've got.
Yes.
We can only test with the data we've got. Is that right or wrong?
Yes, sort of.
Right. We have the data that the Earth is supposedly 24,901 in circumference. That's the data set we've got. We've gone ahead and tested that. We can't find it. So if you're saying the Earth is bigger, give us the data to work with and we'll retest.
Great. That's not the question I'm asking. So the question I'm asking is a yes or no question. And the question
Well,
is,
it doesn't apply, does it?
Yes, it does apply. It's because the problem of underdetermination. It's literally a science question. Does the data measurements that you have taken, are they consistent with both a flat Earth and a very, very large round Earth? Would both of those get the exact same results on the tests you have done?
Only if the Earth was so huge that we wouldn't be able to detect a curve. And
So the answer is yes. The answer is yes.
Only
it is
if it was
with
so.
This
isn't a court of law here, right? You can't do technicalities. Well, he said yes, so he's wrong.
This is not a technicality. This is not a trap question. It's just a basic science question. Is the data you took consistent with both a flat Earth and a very, very large round Earth? Would both of those cases get the same result?
a very, very, very large Earth, right?
Yes.
Which would go against what we see in reality.
Well, of the measurements you've taken, which measurements that you have taken would be inconsistent with a very, very, very large round Earth?
What, me personally or other
Yes, you
people?
personally. You personally.
Okay, yes, still a very, very large Earth. I'd have to recalculate, but I'd have to recalculate based on some data you could give me.
No, no, no. The question is which experiments that you have done are inconsistent with a very large round Earth? Because I think that of the experiments that
Okay,
you've done, none of them are going to be inconsistent with the
okay.
very large round Earth.
Listen, right? With the data that I've got to show me that it's flat, okay? In order, I'd have to recalculate to find out how much bigger the Earth would be so that I wouldn't be able to measure any curvature at that distance. I'd have to recalculate that to tell you how big the Earth would be. But
Yeah.
at this point, right, according to the data set we've been given, right, we can't find a curvature.
Right. So therefore, if you can't find a curvature, there's two possible explanations of that. One is that it's flat, and two is that the curvature is so small that you can't measure it, right? Those are
Okay,
both possibilities.
let's go with that. Let's go with that. Yeah.
Right. So
Now where would we go?
why would you prefer one hypothesis over the other?
Because as I said, if you change the size of the Earth, you throw out everything else.
Well, if you make the world flat, you throw out everything else.
No, you don't.
Yeah, you do.
Well, no, if the Earth was bigger, right, much bigger, okay, the 24-hour day would be out the window unless the Earth was moving a lot faster to compensate for the larger size.
Right. We would have a 24-hour day regardless of the size. So the size wouldn't change
Then the
today.
Earth would have to spin a lot faster
That's fine, but you
to
still have a
account for
24-hour
it.
day. So that's not a piece of data that would be inconsistent. That would be the same
Because
on both.
again, all the other figures that are presented for the Earth would end up being thrown out the window and have to be recalculated for a much bigger size.
And for a flat Earth. So the same thing would apply to
No,
both.
because in the case of the flat Earth, the sun moves around the Earth, not the other way around.
Which you have to throw out the fact that, heliocentrism, the size of the Earth, the speed of light, radio waves, satellites, astrophysics. You have to throw out all of those. You have to throw them all out.
Well, actually, yes, we do, and yes, we do throw them out.
And so but what you're saying is the reason we shouldn't accept a very, very large round Earth is because we have to throw out all of those things.
Okay, then tell me what the size of this new, much larger Earth is, and then I'll come back to you with experiments to show that it's flat.
Well, so what I'm doing here is called a mirroring technique. So I'm showing you that all of your arguments for why you accept the flat Earth would apply equally as well to someone
No,
who's
but
one
you're
accepted
not,
the really,
because
really.
you're trying to say that the data set we've been presented with, right, is fungible. Right? You can
It's fungible.
you can mess around with those numbers, because now we're starting to look at this. You can now say, well, no, what if the Earth was much bigger? Well, no, you can't say what if the Earth's much bigger, because the whole basis of the way this Earth is measured is based on this spinning ball at 25,000 or 24,901 circumference.
Well, so I'm like agreeing with you. Let's assume all of the things you were taught in school were wrong. Now you can assume they're wrong and that the world is flat, or you can assume they're wrong and the world is much bigger and round. Either one of those would be consistent with the data being wrong.
Okay. All right. So we were stuck on this one topic, but then if you're going along those lines, then okay. Then we can go to the actual motion of the Earth. Okay. So if the Earth is spinning at 1,000 miles an hour at the equator, okay, we wouldn't be here, for one thing. Okay.
Why not?
All right, because okay, let's do a little thought experiment, shall we? Let's imagine we're on a roundabout. I don't know if you call them a roundabout in America.
Yep.
Little
the
thing,
drivey things with no lights. Yes.
No, it was just a little thing that kids stand on and they push it round, and They go around.
Oh,
Yeah.
gotcha.
What do you call
I was
that?
thinking like, because we call roundabouts here is like a traffic thing where you get rid of the lights
Oh
and
no,
you
no.
drive with the,
Merry-go-round. Merry-go-round.
yeah, merry-go-round.
Yeah.
Yeah.
So you've got a merry-go-round and it's 8 feet across. Okay.
Yeah.
And you've got two kids on either side of this merry-go-round. Now, if that merry-go-round went round once every 24 hours, okay, you wouldn't notice it. It would be going at 3/16 of an inch, per minute. Okay, you wouldn't notice it, right? Now let's imagine that merry-go-round is a mile wide. Okay, now it's going past that 2.1 inch, 2.1 inches a minute. So I think it's a second. I can't remember. 2.1 inch a second. So you notice it going around like this. Okay.
Yeah. Yeah.
Now let's imagine that merry-go-round is 8,000 miles wide. Okay. Still going round once every 24 hours. Okay.
Yep.
That if you're on that edge of that merry-go-round, you would be flung off because it would be going at 1,000 miles an hour. Right?
Unless you were attached to it by something like a force, like gravity.
Right. Well, funnily enough, you say that. On one of my videos, I have a short clip where somebody has a foam ball and it's got black ink in it, and he spins that ball, and you can watch the black ink sort of collect at the equator and fly off. Okay. Yeah, it's got a wet ball and he spins it, and literally all the water collects the equator and just flings off in a kind of flat plate, as it were. Yeah.
Yeah. Yep.
Right. Now he's doing this vertically, right? So he's spinning it like that vertically.
Yeah.
Okay.
Yep.
The water, some of that water goes upwards. Some of that water goes upwards. Some of that water flings off downwards. Okay. Now I calculated that ball is spinning at 7 miles an hour. 7 miles an hour. Yeah. And yet the water is flung off against the force of gravity, right? Against the force of gravity at 7 miles an hour. So imagine what that would do if that ball was spinning at 1,000 miles an hour.
With no air resistance and significantly more gravity, it would do nothing.
I'm sorry, the gravity of the Earth is where I'm doing this test with the foam ball. Yeah. So
no,
the whole Earth, hang on.
Well, I understand what you're saying, and what you're
apparently not.
I think you're missing is what angular momentum. Do you know angular momentum? That what changes the momentum of motion is the angle or direction it's going and the rate.
Is
so like what about it? That is what?
No, carry on. I interrupted you. Sorry.
Oh, yeah. So angular momentum, the rate at which the momentum of the water is going to change and whether it's going to spin off of the object is relative to the rate of percentage changing in direction, not the speed it's going. And so, like, if the percentage of the circle that it changes is faster than the amount of force being pulled down by gravity, then it will leave the circle. If the percentage it changes direction is less than the amount of gravity, it will stay on the circle. And so if you just put some droplets on there and you make it proportionally change the degrees that it's moving relative to the circle equivalently to the Earth, they will not spin off.
So yeah, that's a fancy way of saying that, oh no, you're not looking at actual linear velocity, you're looking at angular velocity.
Yes.
No, right? I debunk that with the idea of the roundabout. Yeah, that you stand in a like on an 8-foot roundabout, you wouldn't feel anything. You stand on a mile long wide roundabout, you still wouldn't feel very much. But if that roundabout was 8,000 miles wide, yes, you'd be flung off. It's got nothing to do with the fact that at all stages, every one of those roundabouts, they're still going at 20, once round every 24 hours, right? But if you're on the edge of that 8,000 mile wide one, you're going to be flung off, because that edge is going to be at 1,000 miles an hour. You can't
No,
say, oh, well, no, there's no difference because no matter if it's 8 foot wide or 8,000 miles wide, they're still only going round, once every 24 hours.
right. So
No.
they're still only going around once every 24 hours. And as long as the air resistance is the same, like if you put them in a box, so if
Oh,
you
for
say it's in a
crying out
box,
loud. No,
then there's going
because
to be anything. So,
I'm sorry, if you're on this roundabout, which is 8,000 miles wide, yeah,
yeah. Yeah.
and you're in the middle, you're standing on the axis of spin, right? You're not moving at all. Yeah, you're just going round
Yeah.
very slowly, right?
Yeah.
If you walk out to 4 feet away from the center, yes, you're going to be moving at 3/16 of an inch every minute. Okay.
Yeah.
If you walk out to half a mile out from the center, you'll be going at 2.2 inches per second. Right?
Yeah.
Still not hardly feel it. But if you walk all the way to the end, and again, it's going to be proportional, right? The speed you're going to be going is going to be proportional to the distance away from the center.
Yes.
If you go to the edge, 4,000 miles away, you're going to be flung off. Okay. At every point along that journey, he's still going round once every 24 hours. Yeah. But in the middle, hardly move. At the end, right, he's going to be flung out at 1,000 miles an hour.
Why aren't you flung out of an airplane when you're in an airplane going the same speed? So it's like the airplanes travel at, like, you can imagine that the speed an airplane travels is roughly 2/3 of the way to the edge of this very long merry-go-round, and you're not flung off the airplane. Why?
Well, hang on. Say that again. Say that again.
So like we're using the merry-go-round analogy, and you're walking out the merry-go-round, and the further you go out, the faster you're going.
Right.
So approximately 2/3 out of the merry-go-round, you're going to be going about 600 miles per hour or whatever, which is approximately the same speed as what an airplane travels. Now, when you're on an airplane, it's traveling at 600 miles an hour, but you're not flung off the airplane. Why?
Because the airplane usually is going in a straight line, straight and level.
It's not.
Yeah. If that plane was going in an arc,
when they turn, that you're still not thrown off.
Well, you are.
So imagine the airplane.
Hello,
imagine the airplane on a.
You are.
Well, 1 second. So imagine we're on a flat Earth, and there's an airplane above the flat Earth, and the airplane is turning at the exact same rate of, let's say, because you have to be like sitting down. So imagine the airplane is going like up, curved upwards, and it's going up at that rate. Would you be thrown off of the airplane? It's like going up.
So if the plane was going up at 1,000 miles an hour, right, would I be flown off? Is that what you're saying? Well, I'm trying to get the analogy here.
Again, because what matters here is the angular change, not the speed at which it's going up. So, and because we're not standing on the edge of a merry-go-round, we're standing on the top. Remember gravity. So it'd be like, so we'd have to say, if we are sitting in an airplane, and the airplane is angularly like tilting up at the same rate at which you think the Earth is curved.
It would have to be curving. It'd have to be a curved, right? Right. Well, okay. Yes, you would be curving. Yes, you would be flung off. Yes, you would. Okay.
Okay. So again, if it's tilting up, you're being pushed down.
Sorry.
So imagine the plane is upside down. So when it tilts up, you're going down. So it's pushing you down into the seat. You're not going to get flung off, right? Because you're down into the seat. You're getting pushed down because there's this force called gravity. It pushes you down.
In which case, if it wasn't, you weren't on a seat and you were standing, right? You'd fall off it, wouldn't you? You'd be flung backwards and off.
No. So like when the plane goes the other direction and it tilts down, you don't need a seatbelt. You still just stay in the seat.
Okay.
Like when the plane is like decelerating and going down, you can sit in the seat just fine.
Think about this then. Okay. You're in a car. Okay.
Yeah.
Car's going along, and car's going along at a constant speed. And well, you can do whatever you like, and you won't even notice you're moving. Right.
Yeah.
You could juggle and everything's fine. What happens then if the car goes around a corner? Goes around a nice long corner. You get flung to the side, don't you?
Well, it depends how big the corner is. If it's a really, really big corner, you won't even notice.
Okay. Yeah, again, you're trying to confuse things with scale. Yeah. If you're
Wait,
going
wait, wait,
if
wait,
you're
wait. What do you
going
mean confuse things? Because like if the sharper the corner is, the more you notice, right? If you're going at 10 miles an hour and you make a immediate turn, you notice it a lot more than if you're going 10 miles an hour and you make a 1 degree per hour turn. You barely even notice it. You notice it not at all, right? Like it makes a difference how big the scale is. You don't notice the turn if it's a much bigger scale.
Indeed, indeed. And again, I've addressed that idea with the 8,000 mile wide roundabout. Yeah. You
What?
you would be flung off the thing at if you were on
No.
the edge.
As Rubik's boy says, his roundabout example doesn't hold true because it doesn't have gravity as the centripetal force to the spin. His example assumes Earth with gravity in the wrong direction.
Ah, good grief. Okay, here's the other one. Okay, we've got this fairground ride in England. We call it the
Ferris wheel.
oh no, it's the Gravitron. Okay, have you heard of it?
Yes, the drop one.
No. It's a big wheel. Okay, and you stand around the edge, and the thing spins around. And you get stuck to the outside. Yeah.
Yeah, yes.
Right. Now, we have a version where that gravitron tips up on its side. Yeah. And yet people are stuck on the top as it goes round. Yeah. If I
Yeah.
was on the outside of that gravitron, I would be flung off away from gravity. Yeah.
Yes.
Now, that gravitron only goes at 37 miles an hour.
Right.
Okay. Again, it will be the same effect, right? If the merry-go-round was tipped upside down or on its side, and somehow you were able to cling on to it, right, you'd still be flung off 1,000 miles an hour.
No. What is the
Okay, no,
percentage
that wouldn't happen.
angular change of the Earth? Like what percentage does the Earth spin per
It
hour?
doesn't matter.
It does.
If you follow the example of the merry-go-round, yeah. Again, ignoring the gravity part, yeah, for a moment, yeah, just the idea that you're on the edge of a roundabout going at 1,000 miles an hour, yeah, you would not be able to hang on to that thing.
Yeah, yes, you would. You very easily if the gravity was parallel to the centripetal force. And what percentage of the whole thing does it go per hour? What percentage degrees does the thingy spin per hour?
Angular, this idea of angular
Angular
velocity
momentum?
against angular velocity against linear velocity, right? It's an old sad argument. It is.
It's
Okay.
physics. How is that a sad argument?
It's
We can
not
literally prove
physics.
this.
It's just something somebody says, and you call it physics. Yeah, there's a mathematical construction, and then there's reality. Yeah, the
Well,
reality
it's
is that 8,000 mile roundabout is going at 1,000 miles an hour on the edge, and you wouldn't be able to hang on to the thing. Okay. The further out you go on that roundabout, it'll get increasingly harder to hang on to the thing. You'll have to hang on to something to stay standing up. Yeah.
no, it won't.
As when you get out to the end, there's no way you're going to be able to hold on to the thing.
Yes, you will, because gravity's pushing you down. It's pushing, like you don't have to hold on. Gravity is holding you on. That's the point.
Well, as I said, when I did the calculations with a foam ball, and you could see the water droplets flinging off away from gravity, yeah, and that kind of destroys that idea that the Earth's gravity was enough to stop the water droplets from flying off of a foam ball spinning at 7 miles an hour.
Well, that's why I keep asking you about the angular momentum, and you say, well, we just didn't calculate that. So obviously you didn't do the calculation right, because that's part of the calculation. Like it's the percentage, like 15 degrees per hour. That matters.
There are two different things. There's a mathematical construction and there's reality. Okay. Reality is something you can experiment with.
Like with the car example.
Reality is something you can experiment with. Yeah, mathematical constructions are things that you can say, well, this is true because the math isn't
a mathematical construction. Like,
yes, it is.
Is it the case that if you turn 15 degrees in a second, going 10 miles an hour, it feels like a lot. If you go 15 degrees an hour going 10 miles an hour, it feels like a little in a
Again,
car.
it's well,
This
yes,
isn't
but
this is not a mathematical construction. If
again, that is playing around with scale, saying, well, you don't feel it at 10 miles an hour. We're not talking about 10 miles an hour. Yeah?
wait. The point, it doesn't matter if it's 10 or 1,000 or a billion miles an hour. The miles per hour doesn't matter. That's the point. Is there a difference between what you feel, no matter what speed you're going? Ignore the speed. Say speed is speed X. I don't care. You can put any number you want. Does it feel more when you turn 15 degrees in a second, or if you turn 15 degrees in an hour? Which one will you feel more at any speed?
You would, yes, you're right there, right? Okay. Think about this then. I've got a video on
So just I want to pick up on that one
oh, for
point. So
crying
that
out
means
loud.
it's not a
I know, but
mathematical
it's
construction.
scale. But you're just confusing things with scale. You're saying, well, just because people can't visualize, right? A bigger so it must work the same way at
Well,
smaller
no.
scales.
I don't.
No, it doesn't.
I don't want to go that far. I don't want to go that far. What I want
It
the only
doesn't.
point.
We can.
The only point I want to make here is that is not a mathematical construction. That is a fact of physics. So this is something you have to.
There is a difference between looking at a spinning object as in terms of so many degrees an hour rather than miles an hour, right? Because a degree is an arbitrary human construction.
What?
A degree. We've decided there's 360 degrees in a circle. Yeah.
Yes, but the number of the degrees isn't what's important.
Saying so many degrees per hour is different from how many miles per hour. One's physical, one is a human construction.
What?
Say, well, we're only going 10 degrees an hour, and because we've got like 30,000 degrees in a circle, right? So it doesn't make any difference. No, it's a human construction.
What?
We could have made it any numbers.
So are miles per hour. The unit doesn't make a difference. The point is the relative motion in physics.
No. That's not what I'm saying. That's not what, and you know it. It's not what I'm saying, right? The idea, right, of degrees per whatever time period is different from a physical speed of so many miles an hour. Physical miles over a physical time, right? We have a construction of 360 degrees in a circle, right? So no, it doesn't sound very much when we're talking about it.
So I agree those are different things, and I agree the number, the miles per hour or the degrees per hour, are made up numbers. But what matters isn't the numbers. What matters is in physics, are those things that are forces that we actually feel? Yes, like the car example, you agree. We feel the force differently if we turn.
Are my numbers correct?
Which numbers?
You know, when I say at 8 foot roundabout, it's well, you won't be able to calculate it right now, but it will be 3/16 of an inch every minute, and then a mile it's 2.2 inches per second, and at 8,000 miles wide, it is 8,000 miles an hour.
For the speed at which you're traveling at the edge, yes, those are correct.
Right. So what you're saying is, even at 1,000 miles an hour, it is not enough to overcome the so-called pull of gravity. Is that what you're saying?
What I'm saying is the speed doesn't matter because you're missing one of the calculations in physics that we both agree is there. You're not doing the calculation right. There's something else. There's another force there you're not calculating. Like when I asked you, if we do a turn at 15 degrees, if we do that in a second, it feels a lot differently than if we do that in an hour. And it doesn't matter like what speed you're at. If you're doing the same 15-degree turn at 1 billion miles an hour or at 10 miles an hour, if you do it faster, it feels a lot different. Whichever one, the faster the turn feels different, which means there's a force there. Something is different.
There's no force, is it? It's not a force.
What?
It's not a force, is it?
What? Everything is a force. So
it's an apparent force.
Okay. Yes, you feel it. You feel it differently. It feels differently when you turn faster. The faster you turn the faster degrees you turn, the faster you make a 15-degree turn, the more you feel it, right? Doesn't matter
Okay.
what speed you're traveling at.
Okay, let's go with that. Carry on.
And because that's a thing, this is a phenomenon in reality. It feels differently the faster you make the degrees, the faster you turn the degrees, independent of your speed. This is a force that applies in reality that you have to calculate. I'm not talking about gravity here. I'm talking about angular momentum. So because angular momentum is a thing that affects objects, that the faster you turn, the more it pulls you away from the center of gravity. And this is a fact of physics that we know all objects, including those water droplets you mentioned in the merry-go-round, they all are affected by this angular momentum change. You have to calculate this into your model. Otherwise, you're not doing the math right.
Again, the math in this case kind of departs from reality, right? It's a thought experiment. Literally, it's a thought experiment.
How does this depart from reality? Like, we both know this is a fact that if you turn degrees faster, it pulls you outwards more. Right? This is a fact. It's not a thought experiment. This is a fact. You do this in a car every day. The more degrees you turn in a shorter period of time, the more it pulls you outward.
Okay, yes. But
So this is
again,
the thing. This is a thing in reality you have to add into your calculations.
This also affects it as well, because we sense acceleration. Okay, every time we feel acceleration.
Yes,
okay,
I agree.
Now that motion that we're supposed to be feeling on the Earth is acceleration, and we're not feeling it.
That's because the further out you are and the less degrees you turn, the less you feel it.
Okay. Again, we're at a stage of scale where we can't test it. We can't physically test this, right? And so you can
which
say,
thing
well,
can't we test?
we can't physically test, right? That you're right about this. That on the surface of the Earth, right, that spinning at 1,000 miles an hour, you wouldn't feel it.
I guess because we'd have to physically test that, we'd have to build something that's like 1,000 miles wide. So I guess that's true.
Exactly. But again, we can just going by the thought experiment, we can see what that would be like in reality.
Thought experiments don't represent reality. They're thought experiments. Like, to represent reality, you need to test it.
Okay, we know when we go on again at the fairground, yeah, we're on the waltzer, yeah, it's whipping around pretty fast at the edge, but the guy who's running the waltzer, he's in the middle, hardly turning. He can easily walk to you, right? Because it gets increasingly hard for him until he reaches you. Yeah, it gets increasing.
I agree,
and we can extrapolate that out, right?
Yes,
and
I agree.
So that isn't a worthless thought experiment. It is an experiment that reflects reality.
Well, right. So, like, if we were standing on the center of the Earth, we would feel less centrifugal force than we would if we're standing on the edge of the Earth. But that doesn't mean we would be flown off. So I agree. Like, if we're standing at the center of the Earth, we would feel less centrifugal twist. But right now,
somehow you're trying to say that, on that spinning merry-go-round 8,000 miles wide, you can walk out to the edge and still be okay. Even if you had some kind of gravitational force in the middle of that merry-go-round of the size of the magnitude of the Earth, and that would stop you from flying off. Because again, with the foam ball, right? Now those water droplets were flung off. They weren't flung off that quickly. But yet they still overcome the so-called force of gravity.
Yes, but again, what degrees were they moving across, changing per hour? Were they changing 15 degrees per hour? Because if you do that, they won't come off. No matter how big you make the circle, if you make it the degrees they shift per hour, 15 degrees per hour, they will never, ever, ever come off.
Okay. Can you prove that for
Yes.
a ball the size of the Earth? or
I
something like that.
I can pick a ball of any size and I can put water on it and I can spin it at 15 degrees per hour of any size and the water will not come off.
Okay, well, do it. Well, I'm not talking about 15 degrees an hour. Sorry, yeah, 15 degrees an hour. Okay, all right. So, oh, how could you test that? How could you test that actually?
I can build a ball, I can put water on it, I can put a spoke through it, and I can spin it at 15 degrees an hour.
You put a spoke through, and
So like
so
I can have a ball, I can have a metal rod, I can stick the metal rod through the ball, I can put some water on the top, and I can put it on a motor, and I can spin the motor at 15 degrees per hour. I don't care how big you make this. I can make it any size you want. If I spin it at 15 degrees an hour, the water will not fly off.
okay, then make that bottle a mile wide and 10 miles wide. Yeah, that water's going to come off even at 15 degrees an hour.
No, if it's in a bubble, it won't. If as long as I protect it
Sorry,
from
in a
the
bubble.
air, as long as because the air resistance is a thing. So if I like put a fan on it, I can blow it off at 0 speed. So you have to make sure it's protected from the air,
So
and then it won't fall off.
how does the air move with this Earth then?
The air is a part of the Earth. It's attached, kind of like the ground is.
How's it attached? How's it attached to the Earth?
All of the forces of physics, so the electromagnetic, strong and weak forces, as well as gravity.
So you're saying the air, right, as a wodge, is moving with the Earth,
Yes.
like Velcro. How does that happen?
Physics.
Well,
the air is made of matter.
Physics will say that the air at the top will have to move faster than the air down at the bottom.
Or no, it doesn't. Why would it say that? It's friction.
Because
like
it has
the air
because it has to travel a greater distance.
Right, but so does a stick. Like this remote has to travel a greater distance. It's still going together.
So you're saying the air is attached like a stick, is it?
Yes, with the same forces, the strong force,
the only thing that's moving the air possibly is friction. Okay.
Yep.
And the friction between air molecules isn't going to make the air molecule above move exactly the same way. No, if in your model the Earth is spinning, right, it will be the friction of the ground that's moving the air. Okay.
Yep.
All right. Friction of the ground. So the air above that's not touching the ground, it will be the friction of the air molecules that are moving that will try and impart to the air molecules above.
Yeah, so like imagine
and so on and so on. Yep. No, there's no way. You know, if the air is being moved by friction and being close to the ground, and the air up in the atmosphere has no connection to that air, okay, apart from a very tenuous one through friction at every level, no way can it move as an entire wodge of air. No, it would be each layer of air will be moving at different speeds.
Unless there's something like gravity that's holding it together like a sandwich.
Well, okay, so gravity, okay, pulling this way, right? Yep. So pulling this way somehow stops it, stops all the air that's above from moving at a different speed. Is that right? Because gravity is acting this way, yeah, but the supposed spin of the Earth is this way.
Yep.
So how is gravity keeping both levels going at the same speed?
Because there's no friction with space. So like if space has 0 friction and there's a particle below it that does have friction, it's going to get pulled.
Wait a second. You've still got to explain how friction at one level translates to friction, movement at a level above.
Friction is literally the transferring of force of movement from one level to the next level. So if there's 0 resistance here, 1 resistance here, and it hits the 1 resistance, is going to get pulled in.
If I have a flat table full of marbles, okay,
yep.
And I move one of the marbles at the bottom, I start moving it along. Are you saying somehow that movement is going to translate all the way up to the top, right, and move all the marbles all the way along?
Yes, if you had it for long enough.
Wait.
So like if you have like a box full of marbles, and say it's like an ocean or something, and you start moving the ones at the bottom, and you continually move them and never stop moving them, eventually the force will be transferred up to the highest level of marbles. Yes, I'm not sure what the problem there is.
Okay, so how do you get a north to south wind
What?
in that scenario?
But there's no wind in that scenario. It's just marbles.
No, yeah, okay, no, you're saying those marbles equate to what's going on in the atmosphere.
Sure. So in order to get
So,
winds, you need
so
temperature differences.
the Earth
What,
is
what,
moving. The
yeah,
Earth is moving, and the
yeah,
whole atmosphere is moving with it. Yeah.
yeah.
So how do you get a north-south wind while this
Well,
whole
you
thing
need
is
you
moving
need
like this?
well, you need other forces. You need temperature. You need sun heating one side of the planet. You need like an angular thing in order to make the heat not the same. You need slight wobble to it, so it's
Well, I said a north to south wind because if
yeah,
with this model you're telling me, right, there
yeah,
couldn't be a north south wind because the whole system is moving. So it'd be a southwest wind or
right.
northwest wind or something.
That's why you would need something else to cause the temperature difference to cause the wind to go the other direction. So yes, if
Yeah,
there's a temperature difference, if there's other forces going on, other
you're
temperature changes that can cause the wind to go other directions.
missing the
Wait,
point.
no. I agree. I'm agreeing with your point. If literally the only force affecting all of the air molecules was the rotation of the planet, there would be no wind. I agree. There would be no wind. But it's not. There are other forces. There's like temperature differences, and the temperature differences are a different force that cause the marbles to go in a different direction. Like heat causes things to expand, go up. Cold
Indeed.
causes things to go
But
down.
apparently we've got like a default force going on, a default
Yes.
force, the air
Yes.
moving with the
Gravity.
atmosphere. So
Yeah.
how do you get a consistent north-south wind? Yeah, because if there's that default movement, right,
Yep.
it will be whatever wind, north-south wind, will be skewed always.
Yes, unless there's something more powerful than that force to overpower it, like heat, like heat and cold.
Again, this now goes into the whole Coriolis effect now because now you're saying that there's no such thing as this motion, right? There is no such thing as this motion of Earth because they start telling us about some sniper bullets and artillery rounds and stuff. Nobody takes that into account. Okay, there's no motion there. Okay, you're trying to say
Wait,
that.
what? We literally take that into account every day. What are you talking about?
How?
Pilots take it into account. Ships take it
No,
into
they
account.
don't.
Yeah, they do.
No,
Like
they don't.
there was that famous flat earther who bought a laser. What's it called? Laser gyroscope that
Yeah,
all the
ring
ships used.
gyroscope. Ring
They
gyroscope.
literally all the ships use those.
All
So
the ships use those.
yes, ships use those.
Yeah, ring laser gyroscope isn't a gyroscope, by the way. It's a Sagnac device. If you know what that, do you know what Sagnac device is?
Vaguely. Why don't you educate us?
Okay, well, a gyroscope uses principles of a spinning weight, right? And it's the properties of that spinning weight. A ring laser gyroscope is literally a laser being shot and with moving mirrors, and
Yep.
and it detects any drift. And that drift is the ether, not the movement of
Wait,
the
what?
Earth. Is the
We've
ether?
we debunked the ether with the Michelson-Morley experiment. We proved there is no ether.
No, the Michelson-Morley experiment proved the ether, and Einstein had to come along and debunk
What?
that.
What? Like literally, the authors Michelson-Morley literally admitted that this debunked the ether. Like, what are you talking about?
Oh, okay, no, it's the other way round. It's the other way round. Okay, I haven't got my stuff here to hand to actually pull it up, but no, Michelson-Morley, Michelson-Gale, and Sagnac all said that they couldn't find any motion of the Earth. All they could find was the ether.
What? Michelson Morley expected to find that the light beams arrived at the detector at different times. Instead, they found that no matter which direction light traveled, it always moved at the same speed, indicating the ether does not exist.
Sorry, you're getting that off of Wikipedia, are you?
This is an academic source. This is not Wikipedia.
What's the source?
www.amnh.org.
Okay. Well, as I said, I haven't got my stuff to hand here, but again, I can't argue with it because I can't sort of pull up anything to show you.
Well, so the whole point of the Michelson-Morley experiment, they wanted to prove the ether. They believed in the ether, and in order
actually wanted to prove the Earth was moving.
To show the ether existed.
They wanted to prove the Earth was moving. They couldn't prove the Earth was moving. That's the point of it.
Well, the point was to show the ether was there. They wanted to show.
They couldn't.
They couldn't.
They couldn't. It's again misdirection. They couldn't prove that the Earth was moving. That was what
the Michelson-Morley experiment was an attempt to detect the existence of the luminiferous ether. That was the purpose of the experiment. That was the entire purpose.
The Earth was moving. Okay. Again, I'm sorry, I don't have my stuff here to
everyone already believed the Earth was moving. That was not the point. No one cared. That was not the purpose of the experiment. Everyone already knew the Earth was moving.
Well, they proved that it wasn't moving. That's the point. Yeah, they proved it wasn't moving.
What? No, that is definitely not what they proved. Like, no one thinks that.
Okay. All right, that's the same as Aries failure. Everyone says, "Oh, but it was a failure." Don't ignore that. Ignore that.
What failure? The experiment was a success. We like the experiment. It's a progress in science.
I'm saying it's the same spin that's been put on Aries failure, which again proved the Earth wasn't moving. But because it came at, they called it Aries failure, right? Then they put another spin on it.
Aries failure. What is Aries failure?
Aries failure. A guy called George Airy. He proved the Earth wasn't moving. It was the actual stars that were moving.
What? I would love to know more about this. What are you talking about?
Okay. All right. In order to, and I might get this wrong, in order to get a star to be in view in a telescope, right? Because there's a movement there, you have to tip the telescope to actually get the starlight to go down all the way down into the telescope, right? You have to basically tip the the telescope, right? So that doesn't tell you whether the Earth is moving or the stars are moving. But what does is he actually filled the telescope with water, okay, which slows the light down, okay, yeah. And he found, sorry?
I said, yes, I agree. The water would slow the light down. I understand. Yes.
And he found that he would have to tip the telescope further, right, to get the light to go in all the way down to the eyepiece of the telescope. And I might be butchering this, but
that wouldn't make it. That would be the same whether or not the Earth is moving or the stars are moving. That wouldn't make any difference.
If the stars are moving, right, then the light from the stars is already tipped. Yeah. If the Earth is moving, he has to tip the telescope so that it captures the starlight. Okay. He didn't have to he didn't have to tip. So that means the light was already tipped, which means it's the light that was moving, the stars that are moving, not the Earth.
Light goes straight. Light isn't tipped. I don't understand.
Okay, you can pretend you don't understand, but you can go and at your leisure look up Aries failure. And
how do you spell Aries? How do you spell Aries?
A-I-R-E-Y.
A-I-R-E-Y. A-I-R-Y? A-I-R-Y, Aries?
Somebody says it was called failure because it failed to find the ether. It wasn't about finding the ether, it was about finding the Earth's movement.
The Airy experiment. Does
course, pendulum.
Aries
That's another good one.
experiment prove the Earth is flat?
No, no, no. It's there to prove whether the Earth was moving or not.
Well, when I type in Aries failure, it's all about Earth is flat. It doesn't say.
Yeah, that's because there's people trying to debunk it in terms of flat Earth.
Oh, here's a NASA one. Aries water telescope experiments.
That's going to be reliable, isn't it?
Yes, academic sources are typically reliable.
Yeah,
Yes.
NASA. NASA.
What's wrong with NASA? Like,
I
why
can,
do you think it is?
I can see you getting excited over it. Ooh, NASA.
Yes. Like, why do you think all pilots calculate the Coriolis effect and use the calculation? Why do all shipmasters use the Coriolis effect
They
and
don't.
work? They do. What do you mean? They're
They
literally
don't.
taught that. There's literally in there all of the academic books and calculations for directions. It's there.
Well, that's not what the pilots we talk to say. They don't have to take it into account at all.
It's all the pilots I've talked to say that. What are you talking about?
Okay. All right. Well, all the pilots we've talked to, and I think I've only got one on my channel where I videoed it. But yeah, I talk to pilots all the time, every time I fly.
And they don't say that their flight computer literally calculates via Coriolis effect?
Oh no, they don't. They don't say that their flight computer does it. They say they don't have to do it. And if you say their flight computer does it automatically, well, that's kind of black box answer, isn't it? The black box does it.
You can do it both ways. You can calculate with and without, and you can then compare it to the computer's results, and then you can fly and see which one gets it right. And it's the one that uses the Coriolis effect gets it right.
Okay. All right. So no pilot I've talked to has ever had to calculate it themselves.
Does any of them not use the computer and fly over continents?
Well, sometimes they have to go without the computer in an emergency. So I don't know what you're trying to say.
Go without the computer and an emergency. I haven't heard many of those cases. The computer is like the last thing to go.
Not. Okay.
Because I mean, the computer is like what runs all of the gear. If the computer goes, the plane goes.
No, not actually. No, everything's backed up manually, mechanically.
Used to be. Now it's pneumatic. It's
that's
gas and pressure based.
Isn't it? Well, it's mechanically then, isn't it?
With the computer. The computer does the pneumatics. Yes.
And if the computer goes down,
the plane goes down. Because the plane controls everything.
Nope. That would be very dangerous, wouldn't it?
It's safer, actually. Safer than letting
people
do it.
Oh, I hope they're not running Windows 10 then.
We do have some questions from the audience. Unsurprisingly. Udolf asks, what evidence would convince you that the world is not flat?
Okay, well, I'm not sure at this point, because here's the thing. Every sort of item that we look at in the flat Earth, the answer to that is the Earth is flat. When we look at the ball earthers explanation, they come up with different explanations for different phenomenon. Right? Our explanation is one: the Earth is flat. Right? And it explains all of these things. Again, everything. When we look at the speed of the Earth, the Coriolis effect, there's all these different explanations, but we've only got one. So not a lot, to be honest.
All right. Next question is from the nihilist. With the foam ball, the water droplets that go away from gravity, what happens to them after the experiment?
After the experiment, well, after I've gone home, I don't know. Now, after the experiment, they fall to the ground. But the point is, they leave first, and then they come back. I'm not sure we see that in the world around us, do we?
Well, I think its point is that they fall to the earth.
Yes. But it's only a ball that's spinning at 7 miles an hour. Sorry.
Again, it's the degrees per hour that matters there. But would money convince Dave that the earth is round?
If anybody knows me, money's not going to convince me of anything.
It convinced me. I can be convinced that the world's flat for money.
Money's fake, so no.
11th Chimp asks, Ask him if he has calculated the centrifugal force on the equator.
Actually, no, I haven't. There's a lot of things I haven't looked at on the flat Earth, but no. But we should be able to actually detect. I think it was Neil deGrasse Tyson said quite famously that you would be lighter on the equator than you are anywhere else on the Earth. Neil deGrasse Tyson said it.
So I think that's right. I think it's lighter because I think the equator is the furthest point. So yes, I believe that's true.
But is it though?
Yes, we can test that. We have tested that, and you can test that, and you can actually find out. Yes.
Okay. Well, yeah. Why don't you do a video doing that and make sure you don't have a crack before you go down there? So
people have literally done that, and they use standard weight, so they don't use their body weight because you're right, their body weight changes as you breathe, and crap and other things. But yes, you can use a standard weight, and you can measure the weight difference in the equator as compared to not.
Again, I've not seen that. I'd love to see that, and I'd love to verify that as well.
Yeah, that's one you definitely can verify. I would suggest it. You should make a video about that. Would be great.
Well, I did have an experiment I was going to do that was going to be the killer, one way or the other, but lockdown ended that one. But maybe I'll actually get to do it.
Yeah, I think that would be awesome. I would like to see you go with like Fight the Flat Earth or what's his name? Team Skeptic. Have them do that with you. That would be awesome. That would be so much
No,
fun.
I actually had a scientist who wasn't a flat Earth debunker. He was just a scientist who would look at the experiment objectively.
Yeah. So 11th Chimp says the centrifugal force on the equator is about 0.034 newtons per kilogram.
Okay, good. What and where did that come from? Wikipedia? I don't know. How does he know? Did he go himself?
Possibly. I have no idea.
Okay. No.
Stuff weighs less on the equator than on the poles by the exact amount predicted when calculating the centrifugal force from turning once a day.
Okay. Again, does 11th Chimp, did he actually go to the North Pole, test it, take those same weights down to the equator, and correct for temperature as well, and test it himself? I don't think so.
I will wait for him to reply, and we can hear. Next question is from Zap Brannigan. How does Mars do a loop in the sky over time on a flat Earth model? Mars retrograde aligns perfectly with observations of a round Earth model.
As I think his name was George Carey, I can't remember, the Astronomer Royal said, you can construct I can't remember the quote now, but you can't tell the difference from observations on Earth between a heliocentric and a geocentric model, right? From observations on Earth, you can't, right? The wandering stars move around the sun, right? And in the same way. So either way, they look exactly the same. You can't tell from observations on Earth.
Well, his question is how does Mars do a loop-de-loop in the sky? Like on the circle Earth model, it makes a lot of sense that it does.
If you've got the sun, right, and you've got the wandering stars moving around it, yes,
yep.
Okay, it's exactly the same model as a geocentric model. Right? In one of my videos, I show the two models working, and the only difference is where you put your focus. If you focus on the Earth, it's exactly the same model as when you focus on the sun.
So you're saying the flat Earth is spinning in space?
No, I'm saying the sun is moving around the Earth, okay, and the wandering stars are moving around the sun.
So I got that part, but the question is when we look at Mars in the sky, the wandering star in Mars, it goes this way, it stops, it goes this way, and then it starts and goes this way. It does a loop-de-loop in the sky. It will
follow the same retrograde pattern because both models are identical.
Well, the reason it does that on the Earth is because the Earth is spinning.
No.
So why is it doing it on the flat Earth model?
No, it isn't. It's because of supposedly it's because of where it is in the orbit. It's outside the orbit of Earth. So yes, it will do a loop as I believe it says we overtake it.
Yes, and so for the flat Earth to see that, it has to
So
be spinning.
no,
No?
again, if you look at the two models, the heliocentric and the geocentric, they are identical. It just depends on which one you focus on.
I'm not sure that answers, but I'll accept that, I guess. Thank you, Tim, much for the
Well,
super chat. For the
well,
best
what
health and
I'm,
benefits. What? He's
I'm
asked.
sorry.
He asked about drinking urine. I don't know what this is in reference to.
Yeah, this goes to whenever anyone hasn't got an argument with me for me, they go back to the fact that I talk about urine therapy, and somehow he must be a nutter because he talks about urine therapy. You know, let's put aside the fact that I've literally helped people heal themselves with all sorts of things, but you know, let's put that away.
Gotcha. Next question is from. Oh, it's the same one I asked. Tui Lin. Who does Dave think is hiding the flat Earth and why?
Okay, there is a system that an elite class of people that are essentially, well, you can tell it now. They're taking over the Earth right now, and the only way that you can get a small group of people to subdue billions of people is to basically make them feel insignificant. And when you put the ball Earth theory, the Big Bang theory, and the theory of evolution together, you've got this idea that you're nothing. You're a tiny microbe crawling around on a speck of dust in an infinite and uncaring universe. So it reduces you to nothing. And that's how psychologically they can actually start to take us over.
A bunch of people in the chat are asking, what is urine therapy?
Urine therapy is drinking and massaging urine into your body.
What's that supposed to heal?
Right. So, okay, this is a whole different topic, but okay, so urine isn't waste. They've been told it's waste. It's not waste. Yeah, it's the excess of all the good things that have been carried around in your bloodstream. And it's your body doesn't want to get rid of it. Right? That's why it stores it in the bladder, because it can reabsorb it from the bladder when it needs those things. But when that bladder is full and it can't store anymore, the only thing it can do is dump it overboard. And that's it. All the things in urine are life-giving and beneficial. And the medical establishment won't tell you, but they use urine all the time. They just won't tell you.
Well, it's like urea and uric acid and phosphorus are not life-giving. They're acids.
Urea and uric acid are actually life-giving, right? And yes, you can make bloody gunpowder out of urine as well. Urine can be used for loads of things, but let's see if I can remember them. There's the best blood clot thinner, blood clot dissolver is called urokinase, and it's made by a company called Enzymes of America, who've got a subsidiary company, Portaloo or Portajohn. Okay, so they collect your urine, they turn it into urokinase and sell it back to you at a much higher, a huge price. Premarin, pregnant mare urine. Yeah, so that's the top hormone replacement therapy. Murine and Murex, the eye washes. Yeah, take the M off the beginning. It's urine. That's what it is. Yeah. If you're using moisturizers, look on the ingredients. It will say urea or uric acid or something, because it's got urine in it. They won't tell you. That's the thing.
Well, they use extract of the chemicals, which makes lots of sense. Like, yes, there are some healthy chemicals like potassiums and things in urine, but you don't use just urine, because just urine has phosphorus, which is deadly, and the acids, which are not specifically concentrated to the things that can help your body. So
phosphorus isn't always deadly. If it's in a different form, if it's in a different configuration, it's not deadly. Your urine cannot be deadly because otherwise you'd be dead, because it's actually the plasma part of your blood.
if you drink it, and if you drink exclusively urine, you die.
Well, that's what I have been for the last 11 years.
Wow. Okay.
Non-stop.
Okay.
And hello, I'm still here. And not only that, you know, I healed myself of everything that was wrong with me. And
okay.
And well, yeah, okay, you can laugh, but literally,
have
I
you
wrote a
published
book about it.
Have you published it in a scientific journal yet, and won a Nobel Prize
Yeah,
yet? Because
you don't get published for things like that. Just like you don't get published for doubting coronavirus. Yeah, no, if it goes against the agenda, you're not going to get published for it.
it's
Right?
double-blind peer review. They don't see
Right,
anything about.
okay.
Like
No,
I've
you're
submitted
right.
papers
You're right.
myself.
Great. No, great. Yeah, it's all real.
Well, I mean, flat Earth isn't real, but everything else, yes.
Yeah, no, it's all everything you're saying. It's all real. You know, peer-reviewed science. That's real. Absolutely real.
Yes, it is. I agree.
Except it doesn't use a scientific method anymore.
I don't know why you think that.
Because anything that goes against the currently prevailing model is ridiculed, suppressed, hidden. Right? Rather than, oh, hang on a minute, I found an anomaly in our theory, that we've got to dump the theory and try and find a new one.
Well, that's not the case. I've actually had on a expert in parapsychology, and there is an entire journal of parapsychology papers that is accepted in science as published papers, even though no one accepts parapsychology.
No, nor do I.
But they do allow those papers.
Nor do I.
So they're not
or psychology even, but no, the scientific method has not been used for a long time.
At least 6 hours, probably.
At least 500 years, probably.
All right. Latiz Swa asks, ask him how someone in Australia and someone in South Africa can see the Southern Cross due south at the same time on a pizza land south as different directions.
Well, I don't know. And do you have any proof that somebody does? Have you done that experiment? Because I can say anything. I can say, you know, I don't know. I don't know what I'd say, but you can just make stuff up. I mean, have you got the experiment? Can you show me somewhere to go and see that?
Well, obviously not in this particular chat. He doesn't, but I'm sure we can Google it and find it. Yes. Southern Cross. So yeah, Google has access to it, so you can find the details to be able to replicate it yourself. Get the scientific method.
Well, as I said, if we did experiment over Facebook once where we took sightings of the moon simultaneously all over the world, but you know, where's that experiment I can go and see for, you know, about the Southern Cross? You know, people can say things, but, you know, show me.
Also on Facebook, I believe.
No. Again, we use Facebook to communicate instantly, but everyone took photos at the same moment. Okay, so that we just use it as a communication tool.
Well, we can do this experiment on Facebook as well. I mean, because I have friends in
South
Africa. Okay,
go ahead, please.
Sounds fine. Like, we can do that. Sure. Doc Plermonot says the Sagnac effect is used in ring laser gyroscopes on modern aircraft as navigational devices.
Yes, that's what I said. It's not. It doesn't use gyroscopic principles. It uses the Sagnac effect,
which also we can use as navigation. So it does also.
You can use it as navigation, but it's not actually a gyroscope. Yeah. Okay. No, goes into a whole different topic.
It works as navigation because it's a gyroscope, because it measures the movement. If it didn't measure the movement, it wouldn't. You couldn't use it.
They use a gyroscope to measure to measure navigation one way. The Sagnac effect uses a completely different method. They just call it a gyroscope. It's not a gyroscope.
Yep, but it works because we're right about the shape of the Earth. That's why it works.
No. a gyroscope, and this is where it first came out, the whole furore, because gyroscopes, they should, if a plane is flying over the surface of the Earth, okay, a gyroscope will stay in its orientation. As the plane goes over the curve of the Earth, the gyroscope should stay in its orientation, and the artificial horizon should start rolling backwards, right? But that never happens, okay? So it's showing that gyroscope isn't moving, right? Or it isn't actually, the plane isn't going over a curve, because the gyroscope is showing you that it's not moving, it's not going off of a level, right? Because
well, the point here is the Sagnac effect. The reason it works is it can detect rotation in an object at a sufficient speed. And so if you have rotation of this device, it will detect movement. And so the reason it works is because there is rotation that we can measure.
Right. So when that experiment you were talking about, okay, it came out of a film called Beyond the Curve. Is it Beyond the Curve? I can't remember.
The one where we just bought the device? Yeah.
It was a documentary. Right? And but the filmmakers very carefully edited so it would sound like it didn't work. If they'd followed the whole of the, taken the whole of what they'd filmed, you'd see a completely different story. If you go onto Globebusters, the people who they were actually filming, right, you'll get the full story, not the half truth that they gave in that documentary.
Well, I'm not talking about the documentary. I'm just talking about the Sagnac effect and every one of those gyroscopes. The reason that they detect movement is because what the Sagnac effect detects is rotation of an object. If you have sufficient rotation, you will get a measurement. And so the reason we get a measurement from those devices is because the globies are correct.
As I said, the reason you brought this up, actually, as if you remember, is you talked about that documentary. As I said, they did that experiment. The documentary carefully edited it so you'd get the impression that it didn't work. If you go to Globebusters, right, find Globebusters on YouTube, right, they will explain, because they were the ones who were being filmed, they will explain how it was just edited so it looked like it didn't work. And now they go through it in detail.
Okay, so just to clarify, the point the commenter is making is saying the Sagnac effect proves the world is rotating. I don't care about the film. The film doesn't matter. The point is that the Sagnac effect, if you detect movement, it proves the thing is rotating. That's the only thing it's making.
Again, this is from that Globebusters experiment, and they showed that what that documentary showed wasn't true. Okay, experiment.
I don't care about the documentary. I don't care about the documentary. I'm just talking about just the Sagnac effect in general.
I can't talk about that because I didn't do that myself. I wasn't there. Right. That's why I'm trying to redirect you to Globebusters who did do that, and they did it for that documentary, and that documentary was skewed so you'd get the impression it didn't work.
Okay, that's the part I was missing. Like you were saying, you didn't do the experiment, so you can't comment on the Sagnac.
I can't. I didn't do it.
Gotcha. Brenda asks, "What is the gravitational attraction of the foam ball in the water experiment?"
Yeah, it's a bit sarcastic. Yes, it wasn't about trying to measure the so-called gravitational traction of a foam ball. It was the fact I mentioned it because the speed of that ball rotation, the speed of its rotation, right, was only 7 miles an hour, and yet it flung the water off against the pull of the gravitation of the Earth. Nothing to do with the gravitational attraction of the foam ball.
Gotcha. Jeff asks, has Dave set up his own Foucault pendulum?
Don't have to. There are so-called Foucault pendulums all over the Earth, but they don't spin. They don't move. Yeah. Every time you see one of those large cranes, right, with the thing hanging down, the weight hanging down, they're not spinning.
Yes, they are. They do actually. They do actually.
No, they
move,
don't.
But
no, they don't. And the Foucault pendulum, right, will not move by itself. They have to be moved. Right. They have a motor. They have a magnetic mechanism at the top to keep it swinging. Okay. So no, and also there's a thing called the Elias effect. If anyone's heard of that, the Elias effect is when there's an eclipse, the so-called pendulum goes backwards for no apparent reason, called the Elias effect.
All right. Matthew Furs asks, if he lives long enough for commercial spaceflight, will he think the windows are green screen? What if he is floating in outer space?
Well, the answer is you're not going to live long enough to see that, because funnily enough, if you follow the media, every 10 years or so, they'll say, oh, hotels in space are 10 years away. And then you get 5 years further on, they'll say, oh, no, they're 15 years away, and so on and so on. They keep pushing it back because you'll never, ever get there because it doesn't exist.
So if you did go up in a spaceship and were in space, that would convince you?
If well, I say that. Did you ever see? There's a TV show in England called Space Cadets. Do you ever see that?
Mm-mm.
Okay, so Space Cadets got a whole group of people and told them and put them through like obstacle courses and fitness things, and said, okay, the winner of this competition will get to go to space, and they literally faked taking them to space, and they believed it. So yeah, that I could be fooled, but just like the Space Cadets were fooled.
That's what the question was asking. Would you believe you were fooled, or would you believe that it was legitimately space?
I'd probably start looking for evidence of me being fooled, and the Space Cadets believed it, hook, line, sinker, and I think I'd like to think I would have spotted some things, but maybe not.
Samir, thank you for the super chat. Samir asks, if you travel east from New York to London, then east to Istanbul, east to Tokyo, then east back to New York, how is this possible on a flat Earth?
Okay, first of all, I have to look at the flat Earth map and see, and then plot those.
Do you have a flat Earth map?
Not to hand. But here's the thing: east is not a direction. East is a circle, and even on a globe, it's a circle, right? Think about it. East is always having north to your left. Yeah.
Yeah.
So you travel forwards. North is always on your left. Okay. So if you start traveling right in a straight line, well, north is no longer to your left, and you have to adjust yourself so that north is to your left. So east or west is going to be a circle. So again, I'd have to plot it, but unless all those lines, all those places are on the same latitude, then it's impossible on a ball as well.
Gotcha. Mike Schnapp ask him what the motive for NASA or whoever is to perpetuate the globe Earth view.
Well, yeah, I already kind of answered that. It's essentially to weaken us psychologically.
How does that weaken us psychologically?
Again, all right. I'll say again. So the ball Earth view, the theory of evolution, and the Big Bang theory. Put them all together, you get an insignificant microbe on a speck of dust hurling in an uncaring universe that all came about by accident. Your life doesn't matter. You've got no purpose. And so powerful people down here can give you a purpose. And they do. And that purpose sucks.
Foxtrot Red asks, is Mr. Dave a religious man?
I am absolutely, completely and utterly not a religious person, though I totally know that the Most High exists, but I'm not in any religion whatsoever, and I'll stay away from them until the day I die.
Gotcha. 11th Chimp says, Where's Wally did do exactly the measurement thing where he took a weight to the North Pole and the equator, and there is a video of it. Lots of people have done it.
Okay, well, perhaps you can pass that video over to me and I'll have a look at it.
All right. Nihilus asked, what is the force that moves the sun in a circle over the Earth on the flat Earth model?
I don't know. I'm not the most high, you know. If I was to guess, I would say something along the lines of quantum locking. If anyone's seen that, that's a very interesting effect. Have you ever come across that?
Quantum locking, the thing that happens on the particle level, and you say it happens to the sun?
No, it's not on a particle level. They've actually done it with magnets.
Magnets. So the sun is a magnet?
I'm not saying that. I said if I was to guess, I would say something akin to quantum locking. And if you go and look on YouTube for examples of this quantum locking effect, then you'll see what I'm talking about.
Legendary Abdurrahman asked, TJump, why are you more patient with guests who are white? I'm not. Check my debate with Jay Dyer and Jack Ingstreich. I am equally as not polite to everyone of all races. Brenda asks, what is not with the sun following a racetrack over the... Oh, talking about the perihelion of Mercury in the sky doesn't work with the sun following a racetrack over the Earth if the world is flat. Okay.
Well, am I supposed to respond to that? I didn't see the...
Yeah, so the initial question was how do you explain the perihelion of Mercury on the flat Earth model? You said it's because in a geocentric and in a heliocentric model, the model is the same and
they're identical.
And then Brenda says, if that's the case, the perihelion would not be explained if the sun was going in a racetrack over the Earth because it wouldn't be the same.
Okay, if the two models are identical, then they'd be the same, wouldn't they?
That's what identical means, yes.
Yeah, but they're right. They are identical.
But it wouldn't be identical if the sun was going on the racetrack around a stationary Earth. That would then not explain. The perihelion of Mercury would be very strange. It'd be like the stars are moving randomly for no reason.
As I said, the two models are identical. So how Mercury moves, in the geocentric model is the same way the Mercury moves in the heliocentric model. If I could show I haven't got my thing up here, but I could show I've got a slide that shows the two models, the heliocentric and the geocentric. And, if you focus on the sun in the heliocentric, yes, there it goes. If you focus on the Earth in that heliocentric, it moves exactly the same way as the geocentric model that's right next to it. It's just your focus shifts.
11th Chimp gave a link to Bob the Science Guy's YouTube channel to show the weight experiment thingy. So you can check Bob the Science Guy's channel.
Just send it to me and I'll take a look.
Liam Bitcoin asks, why is the moon inverted when observed from the two poles?
That's a bit of a silly one. Okay, so if you and I were standing on opposite sides of a room, okay, and I drew an arrow pointing to you, right, on the ceiling, right, you're going to look up and you're going to see that arrow pointing to you, aren't you? I'm going to look up and I'm going to see the arrow pointing away from me.
Sure.
It's your perspective. It's where you're looking from.
Night Sky Jeff asks, how far is the moon from the flat Earth?
Well, it's been estimated at 3,100 miles, or right thereabout.
Okay. Rubik's Boy asks, how do you explain the massive technological progress in the last 500 years without the scientific method?
Okay. Well, when I said 500 years, I wasn't serious. I just pulled a number out of the air. But scientific progress hasn't come out of the academic institute. It's come out of people inventing stuff. It's not the academic world does not produce invention. Yeah, they might document stuff, but they don't produce anything. They don't drive technological progress.
Like literally all of it's from like all of the, what's it called, the nuclear research done by the government for atomic research, Michael Feynman, von Neumann, the stuff before at the end of World War II. It was all sciencey guys making that research.
Right. Well. Okay. So like a nuclear power plant, for instance, you think that's a pinnacle of technology?
It's pretty good, yeah. Nuclear.
No, it's 19th century technology.
Fission.
It's 19th century. It is 19th century technology. If you pile enough uranium together, it reaches critical mass. It starts heating up, and it basically boils water, drives steam engines. It's 19th century technology. It's not massively sort of highly technological. No, not at all.
It's super technological to prevent it from going critical and killing everybody. It's extremely.
You stick a carbon rod in it, and it varies. It sort of mediates the temperature. Yeah, they were doing it in. I believe they were doing it in Africa. Right? Literally piling uranium together and sticking sort of burnt wood, charcoal, tree trunks or something in there, right, to regulate it. It's not new technology.
And nuclear fusion today, which is all done by the scientists, that's also not technology. No.
What fusion? Where's that? Have you got Mr. Fusion on your car? Have you?
Tokamak? Yeah.
You've got a tokamak in your car. Wow.
Absolutely.
You got a DeLorean, have you?
Samir, thank you for the super chat. Is it more accurate to describe Earth as a giant pizza floating through the universe than a globe? If so, what's on the other side of the pizza crust?
Nope. This is a realm, and there's other people who believe different things, but I believe this is all there is. This is the universe. There is no outside of here. Right? This is it. So, saying what's on the other side of the Earth is the same as saying what's on the other side of the universe. It can't be more space and time, because that would be more universe.
So you're saying that the top side of there is no bottom side to the flat Earth?
No, I'm not saying that. Okay, we found that there was a rocket called the Go Faster rocket that was launched in 2016, I think, and it went up 75 miles, and it hit a non-physical barrier about 75 miles up. Literally, it was shooting up in the air, spinning wildly, and all of a sudden it went dunk and then fell back to Earth. Yeah, all that forward motion was stopped, all that spinning was stopped immediately, and it fell back to Earth. Okay. There was a guy called Mike DeGruy who took a mini sub to the deepest part of the ocean and found there was a non-physical barrier stopping him from descending further down into the water. I believe that this is a realm, and you can't get out of it. There isn't. This is my view. There isn't space or time beyond this place.
Well, I think he's asking, in your worldview, what do you think is below the flat Earth?
And I'm saying nothing. You can't. We don't know. It's the same as saying what's on the other side of the universe. If the universe is expanding in your model, then what's it expanding into?
Oh, so you're just saying you don't know. So because
I don't know, just like science
Gotcha.
doesn't know what's on the other side of the universe. My model is the same.
I was getting confused between. I was thinking you said there was no other side. Like there's just literally. When you said that you don't believe in space time, I thought you mean like there's literal nothingness there or something.
I don't know what it is. But even nothingness means space.
Yeah.
Yeah. Oh. So I don't think there's space or time. Just like, as I said, the conventional model says, well, it doesn't say what the space and time is expanding into. It can't be more space and time, otherwise that would be space and time. The universe, if it's expanding, it's expanding into something. What is that something? So I'm saying same model, just smaller.
Bob asks the same question. Why are we being told the world is a globe?
Well, I'm not going to say it a third time.
All right. Colin asks, was Dave there to see how the editors of Behind the Curve edited the documentary?
No, I wasn't, but I am friends with Bob and Jaron and the ones who were in that documentary, and I speak to them.
Gotcha. Julian Galdau asks, why does a physical gyroscope also detect a drift? How should it detect a rotating ether, or does it detect something else?
A physical gyroscope does not detect drift. There's a guy called Rob Durham, and he bought a precision gyroscope, and that was motorized, and he ran that thing for 6 hours. And you can watch him on YouTube where he speeds it up the whole 6 hours, and that thing doesn't move. Now we're told that Cavendish did the same experiment with a wooden gyroscope, with a pull string, and somehow managed to detect the Earth's motion. No, where there is no drift, there is no motion detected by a gyroscope.
Gotcha. Next question is from Molasses. If water seeks its level, does urine do the same?
Yeah. Okay.
Troll
Yes, it does
question.
actually. Yes, it does.
Okay, fair enough. Brenda asks, Dave's standard is he needs to personally witness the experiment, so he can't then appeal to anything outside of his own personal experience.
No, I'm saying I can't make claims on something I've not experienced myself. So if you say, "Oh, you weigh less on the equator," well, I have not experienced that, and I have not seen that convincingly shown to me. So I can't comment on it. And if you say you
Gotcha.
can, then I don't think that's intellectually honest.
Neon Soul asks, ask him how he explains star trails at the equator.
Star trails at the equator. Okay, you might need to go into a little more detail, but I guess I can say everyone's viewpoint. You've got your own sort of personal globe, okay? Because of perspective, right? You can only see so many things because of way things set as they go further away. Or you go further away from them. So if you're standing at the North Pole, obviously the pole star's right above you, right? And you see a certain number of stars around that. But if you start going further south, the North Pole starts to get lower in your field of vision, right? And you start seeing different stars because you've got a personal dome of vision. And no matter wherever you are on Earth, you've got a different dome of vision, if that makes sense.
I think star trails are mean like if you use a long exposure camera, the stars will go straight from the west to the east, whereas if
Sure.
you're closer to the north and south, they go in a circle above your head.
Yes, it's exactly the same on a flat Earth. You've got a dome of the stars are in the firmament, and it's the stars that are moving around. And again, you've got a personal dome. So the further away you get, right? Yes, the stars on your horizon are going to be going sort of east to west or whatever, going sort of across rather than round in circle.
Gotcha. 11th Chimp says Elias effect is just an assertion. It has never been measured.
Then why is it why is it a thing where people have said we see this the Foucault pendulum going backwards? If it's just an assertion, I can assert anything. Why has it become an effect just because I say so? No, it's been measured, and people don't like hearing about it or talking about it, so it's suppressed.
How can a
It's
Foucault pendulum
exactly
go backwards?
it goes backwards during an
What is
eclipse, and nobody can explain why.
goes backwards during an eclipse?
Yes, called the Elias effect. And we didn't make it up. It was already there when when we came along.
Mm, Inconclusive or negative results. That's what it
Pause while
seems to
you look it
say.
up on Wikipedia.
Yeah, I was Googling it. It's interesting. I wanted to look it up. That's what you're supposed to do.
Well, there's other things along those lines, like the selenalian. Okay. Again, most people haven't heard of it because you're not meant to hear about it. Have you heard of a selenalian?
Nope.
A selenalian is when there is a lunar eclipse, right? When the sun and moon are in the sky at the same time, which means the Earth cannot be casting a shadow on the moon. And these selenalians are quite frequent. But nobody hears about it or talks about it because it destroys this idea that the lunar eclipse is caused by the Earth's shadow on the moon.
Brenda says the selenalian is easily explained.
Oh, really?
Thank you for the super chat, Drew Perot. Where did it go?
On the selenalian idea, what's not easy to explain is the fact that on many of these selenalians, the shadow comes from above rather than below. So what's casting the shadow if the shadow is coming from above and both the sun and moon are above the Earth? Easily explained.
Drew Perot, thank you for the super chat. Why does Dave look like he's from Django Unchained?
Because I'm about to do the same thing as Jackner.
And Raz Putis asks, where can you buy the drugs that this man uses?
I'm selling them. If you just give me a chat and I'll let you have some. They're good stuff. It's yellow and it's liquid.
Liquid phosphorus. Jeff asks, does Dave have any of his own experiments planned? I'd recommend a Southern Hemisphere trip to do a stargazing and his own Foucault pendulum.
Again, I do have an experiment planned. It got cut short by the lockdown,
COVID.
But I will say, okay, on the strength of this experiment, I asked two people, somebody who's for flat Earth and somebody's against the flat Earth. They're already putting up a large sum of money for either, proof either way. Okay, so on the strength of this experiment, I approached the ball earther and I said, I approached the flat earther first. I said, look, got this experiment, right? This is how it's going to go, right? Would you put up something like $50,000, right, on the result of this experiment? And he said yes. So then I went to the ball earther, who's already apparently putting up something like $50,000 US Australian dollars. It was. I said, okay, I've got this experiment. The flat Earth guy's already said yes. Would you put up the same amount of money or whatever you decide on the strength of this experiment? He said no. That tells
I'd say
me a
no
lot.
too. Well, I mean, if you wrote the experiment, I wouldn't put money down on an experiment somebody else designed. Like, no way I would do that.
Okay. So what I explained to both of them, right, was that the experiment will be in a sealed perspex box, and it will be in front of a scientist, so that neither of us can touch it, and it will be in front of an independent scientist who doesn't believe in the flat Earth, right? And it will be in front of the scientist for the whole length of the experiment, and neither of us will be able to touch it, and it will have a definitive answer one way or the other at the end of it. And before we start, we agree what the results will mean. So if it went one way,
who gets to build the scientific experiment? Because that's the part that I'd be concerned about. Like, if you get to build it, I could build a box that gives me any results I want. The question is who gets to build the experiment, and I would need it built by an independent party who's like scientifically rigorous, and then do the experiment for it to be trustworthy.
Well, here's the thing: the experiment is very, very simple, and because it would be in a clear perspex box, there's nothing to hide. It's very, very simple, very straightforward. And if there was any trickery, you could see it. It'll be
Well, have you seen
very
Penn and
obvious.
Teller? Like you could build a box that's with clear plastic things that can give you any result you want. So I would need something. I would need an independent panel building this box to trust it, because Penn and Teller can build you a crazy box that can do all kinds of stuff that you can't see what it's doing. So
Okay.
I would
Well,
not.
again, this, you know, I'm not here. I'm not actually trying to find evidence for the flat Earth. This experiment was to say, right, this experiment will go one way or the other. I don't know, right? And I said this to both of them. I don't know whether it's gonna show a flat Earth or not. Okay.
All right. So I
Right.
agree with what you're saying. I would find the scientists not being willing to put money on it as a reasonable decision to make, because we know that there are people like Penn and Teller who can make a box that can deceive you. And so I would also not put money
Sure.
on it if somebody else built the experiment and I don't know what the criterion was.
Okay. Well, this guy didn't even sort of say that. He just was like, nope, not doing that. And if that was a concern, if it was you, for instance, and you know, I was trying to get you to get on board, I would take what you said into account and say, okay, you know what? It's a simple thing. I'll get the scientist to put it together. Right? I'll put all the pieces, because it's a very simple experiment. Get the scientist to put it together and put it in the box and seal it. Okay,
Gotcha.
and have it in front of him. All right. But yes, if things go well, I'm going to do it again, but this time without the cash prize at the end.
Gotcha. All right. Lael asks, Dave, can you explain how sunrise and sunset work on a flat Earth without phases like we see too far, etc.? Or please give an actual distance of how much is too far.
Okay, how sunrise and sunset works.
I think it means
Imagine
like this, we stop seeing the sun as it goes over the horizon, but if the world was flat, we would just keep seeing it smaller and smaller and smaller and smaller.
Okay. Well, okay. Imagine yourself in a long corridor, and that corridor is a mile long. Okay, and the only light in that corridor is a light bulb, right, on the ceiling a mile away from you. Okay, so you're standing in a completely dark corridor. Right, now let's say you start walking towards that light bulb. Eventually you'll see that the corridor ahead is getting lighter and lighter, right? And eventually a tiny pinpoint of light is going to appear on the horizon. Okay, and as you walk closer and closer to it, it will rise up higher and higher until it is directly over your head. All right, and then you can keep walking and looking back. And as you walk away and look back, that light is going to go, you know, get lower and lower in your vision, right, until it disappears behind your vanishing point.
Right, I would agree, but you would see the bottom and the top of the sun would come over the horizon at the same time in your experiment. But if we don't see that, we only see the top of the sun and then the top of the bubble of the sun and then half of the sun, and then
Actually,
later we
no.
see the bottom. What?
Actually, no. We've done experiments with a P900 camera, and what we see, it depends on the atmospheric effects, but most of the time what we see is the sun start to get smaller and smaller, and it will start to merge with the horizon, because there's a kind of band of reflection called a Fata Morgana, and literally the top of the sun starts to reflect below, and it gets smaller and smaller, and then it fades out altogether, because light will only go through so much atmosphere.
So you're saying there's atmospheric light bend is the reason that it doesn't.
I'm saying that that light will only travel through so much atmosphere, and to say at high levels of zoom, what you see is the sun doesn't disappear behind the horizon; it literally fades out. And I could show you some of the videos that show that.
Brenda says the P900 is a horrible camera.
Well, it's been good to us.
Vlad the Stoner asks, is the flat Earth round? If so, why? How? Why?
It's roughly round. It's akin to a lake, so it's a roughly circular lake.
And why? Is there like an explanation to why?
Because the edge of the lake is what we call Antarctica, which is ice. And we have a big yellow hot thing that goes around the flat Earth, melting out a puddle. So it's going to be roughly circular, isn't it?
Gotcha. Anthony Sorrells, thank you for the super chat. Dave, you're talking to people that have not honestly looked into the globe yet. Hopeless.
I know. And people think there's certain people, whoever it is, Anthony, yeah, there's certain people who think they're really clever and they've got science up here and they can look things up on Google and that makes them really smart. Yeah, I know what you're talking about, mate.
Gotcha. Samir, thank you for the super chat. Are the other planets flat too, or are we the only frisbee in the ball game? Every amateur can see other planets spin with a $100 telescope, can't you?
No, they're lights in the sky. They're called, the word planet means wandering star. That's what they are. They're the wandering stars. Okay. And what stars, one possible explanation for stars is that we see stars on with the P900 and they look very much like sonoluminescence. So when you put ultrasonic sound into water, you get what they call a star in a jar. They look very, very similar. So no, they're not flat. They're points of light.
Gotcha. Super chat. Thank you for the super chat, Lyle. If I am looking at the sun on the horizon, exactly how far is that horizon? I am 6 feet tall.
3 miles.
All right. Rob Simpson asks, so many fields of science rely on the assumption the planet is spherical, geology, astronomy, communications, etc. At what point at university does NASA approach you and recruit you to lie?
They don't, and you said it right there, an assumption. It's an assumption. There's no basis to it. It's an assumption. Enough said.
All right. Clinton Roush asks, oh, thank you. Appreciate it. Rob Simpson.
What about mine? What about mine?
well, you're laughing, so it doesn't count. You're not containing the laughter. Yeah. Rob Simpson, why doesn't Russia reveal the flat Earth to show the Western world and their government lies to them, but Russia will not, and ultimately prove the propaganda of Russia?
That supposes that we don't already have a one world government. We've had a one world government for a long time, a very long time. And they just haven't revealed it to us yet because the proles would start kicking off.
All right. Bob asks, are any of the other planets flat? And you're saying they're not planets. They're just lights.
They're lights in the sky. You can't land on them. They're not rocks.
Okay.
You got that contained laughter there. No, look at Mars. Yeah, what they're showing us as Mars. It's Devon Island. You go to Devon Island and they saw on one of the pictures from Mars there was an Arctic rat. There was a dead Arctic rat in the picture. Right, the same kind of animals that roam around on Devon Island. Yeah, it's no.
Must have missed that rat on Mars. That would be interesting. Foxtrot Red asked Mr. Dave if nuclear weapons are real or not.
I personally don't think they are, to be honest. Based on the testimony of a guy called Galen Windsor, and my friend who went holiday to Hiroshima and several other things. So no, I don't think they're real. That's just my personal view.
Gotcha. Melody Joy asked, do you believe in a dome?
I do, actually. I absolutely do. It's incredible that there's a book that's been with the human population for the whole of human history. And that book describes a flat Earth with a dome.
Gotcha. Doc Claremont asks, what is redshift or the CMB measuring?
Well, if you're going to try and say CMB, which is the cosmic microwave background radiation, somehow proves the ball Earth, well, it doesn't. It actually proves that the the Earth is in the center of the universe.
Well, I think his question is specifically, in your worldview, what specifically are those devices measuring in your worldview?
In my worldview, redshift is, again, based on assumptions, many assumptions upon assumptions.
So
Assuming,
what is it that it's measuring? What is it looking at? If it's not the redshift, what is it that it sees?
again, it's based on the assumption that okay, you know what color the star is in the first place, and you know, it's based on assumption. Oh, this amount of redshift means it's moving away from us. You know, no, you know, you've got to make a whole load of assumptions to get to that point.
Isn't it the case that if an object's moving further away from you, that like any kind of wave, sound waves, light waves, they get longer when it comes towards you, right? Because the speed subtracts.
Indeed, but again, to say that that's what's occurring with these stars you have to make several assumptions before you get there.
Well, I think it's based on the pattern that as we look at them, the further away, the fainter they are, the more red they are in every direction we look. So unless all of the stars in every scale are the same color or something, it would make more sense that they're all traveling further
so
away.
you're saying that stars all shine at exactly the same intensity.
No,
that's an assumption. Well, no, because you just said the further away they are, the fainter they are.
Yes,
that's an assumption. That is an assumption, right? Because if stars aren't the same intensity, then you could have a faint star that's close,
right?
In your model,
that happens. That happens.
So how do you know? How do you know that's not a faint star or it's a star that's far away?
Well, because
there is no stellar parallax. There is no stellar parallax. Nobody's ever measured it. So no, you can't tell. You make assumptions.
Well, intensity doesn't.
That's what most of science is. It's assumption built on assumption built on assumption.
Well, again, that was not part of the analysis here. The point is that there's a pattern to them. Like as we look at them, some of them have this redshift, some of them have a different redshift, and it seems as we look at them, the ones that have the longer redshifts are like further away for lots of different reasons. But why do you think there's a pattern?
Assumption.
Not farther away. All right, Dr. Valerian, thank you for the super chat. After the sun reaches its lowest point on the flat Earth, it would then move 8 degrees back on itself. This would have the sun double back on itself, and time would go back 30 minutes on a sundial.
What?
I don't understand the question either exactly.
No. We don't see that every day. We don't see the sun moving in the way he's talking about. I don't know. Don't understand that.
I'm not sure. Doc, if you have a clarification, let us know. Brenda asks, Brenda would like to debate Dave, maybe on your channel with you as a mod. Would you be up for that, Dave, to debate Brenda?
Is it going to be the same sort of thing? Because unless it's going to come up, going to come up with something a bit new. I don't mind, but yeah, sounds like a rerun to me.
Gotcha.
Unless you want to talk about something else.
I'm sure there are other topics related to urine that we could definitely discuss, so get lots of views. Rob Simpson asks, why are the only people to know the flat Earth shady loners?
That is an artifact of being a flat earther. It's an artifact of going away from any norm. As soon as you depart from any norm whatsoever, you become a loner and an outsider. That's the way this world is.
I think his question is more specifically like there are academics who believe in idealism, that consciousness is fundamental, or they believe that climate change is a lie. There are many different academics who disagree on lots of things, but this one, it doesn't seem to be the case. Why are there no like academics who think the world is flat?
Because if you're an academic, if you're a scientist, for instance, or if you're an astronaut, whatever, if you don't believe in that model, you don't become one. Yeah, you don't get there. You answer the questions wrong on the tests. Yeah, you don't become a scientist if you have these beliefs. Yeah, so no, it's an artifact of believing it. As I said, if you depart from the norm in any sphere, you become an outsider, you become a loner, and everyone regards you as having dodgy beliefs.
Well, that's why I mentioned like climate change. There are a small number of climate change denial scientists, but they're not like kicked out. So
right. Well, I totally don't believe in climate change because even well before it even became a thing, I found out about it. I found out about the Club of Rome and Aurelio Pesci, who actually said we're going to use climate change as the next bad guy. He said it right there in one of his documents, and then Club of Rome member Al Gore went out and started talking about it and got it into the mass consciousness. It's a plan. It's not anything that's real.
oops. So super chat from Lael. One sec, I accidentally hit it. Dave, what is interesting is the physics that TJump had on his the physicist that TJump had on his show last night, and he said in his experience he has never met any scientist that believes the Earth is flat.
Right, and as I said, if you want to become a scientist, you have to go have exams and stuff. And if you don't believe the current prevailing model, you get the answers wrong on the test, and you don't become a scientist. And or you hide your beliefs, and if you ever try and express them, you don't get funding, and you get ostracized.
Gotcha. Dr. Claremont added clarification to his super chat. The inconsistent angles of the relationship between the Earth and the Sun prove the round Earth model, and the sundial works correctly.
Well, the sundial only works on a flat Earth. The sun going around the Earth on a flat Earth doesn't work on a ball. How does it work on a ball?
All right. I draw stuff. Dave, we say we find incontrovertible evidence that now scientific consensus is that the Earth is flat. What do we do first?
We ask where the money's going to in all these so-called space agencies. That's the first thing I'd say.
Gotcha. Clyde Sutherland from Facebook asks, have you experienced an eclipse?
A partial eclipse. One happened in England, I think, in 2017, I think. Yeah.
Gotcha. Raz Putis asks, if the world is flat, where are the photos?
If the Earth was a ball, where are the photos? Yeah, we don't have any. We've got images that are knocked up by people in NASA. They knock them up. The main guy at NASA who's doing it, a guy called Rob Simon, he actually explained how he does it. He explained in detail. He goes, I put this bit on here to simulate the Earth's atmosphere. I put this specular highlight to simulate the sun reflecting off the water. I put the clouds in and I make them look see-through and make them. He explained the whole thing. Right? There are no photos of the Earth. So no, we haven't got them because we don't have the means to take a picture of the whole Earth, just like they don't have the means to do the same thing.
Another viewer says the communication satellite G19 is 22,000 miles from the surface of the Earth. The math used to aim it would not work if it was any closer.
Okay, if that's what you say, if you believe. But here's something I believe. Yeah. Now, low Earth orbit is from 99 miles, right, to I believe 1,200 miles. Okay. Now, I actually drew up the Earth, to scale on my computer, and so I had the Earth here, the sun over here, yeah. So the Earth was half in sunshine and half in darkness. Okay, now I can lie in a field at midnight and look up and see what they call satellites moving overhead slowly. Yeah. And they say these are satellites, and you can go to satellite tracking apps and find them. But if I'm lying in a field at midnight, that means the sun is directly the other side of the Earth from me. Okay, so those satellites would be in darkness. they would be in the shadow of the Earth, and so I wouldn't be able to see anything, right? Because these satellites don't have lights on them, so they could only reflect the sunlight, and they can't reflect the sunlight because they'd be in the shadow. Okay, and even if they were reflecting, somehow they were out of the shadow and were reflecting sunlight, they wouldn't reflect a steady light down towards me, because these satellites aren't perfect spheres. They're angular shaped things with solar panels and whatever. So they should be glittering because the light should be catching them every now and again. But that's not what we see. So
Gotcha. Homier asks, explain the fact that as civilizations became more progressive, and there's a second part, they all seem to have conspired to figure out the Earth as a globe about 2,000 to 3,000 years ago.
well, I think it's a lie that the Earth has become more progressive. We see lots of evidence of previous civilizations not doing things that we can't do today. We're finding, if you go and find I think there's some books and a site about out of place artifacts, you'll find things like watches being found in deep levels of Earth strata. The story that we've been given about our origins is not true. There's something else going on. So I don't think we've got more advanced. I think we've got more stupid, to be honest. And we just regard these simple toys that we're using, right, as somehow evidence of high technological status. I don't think so. I think there was a better technology around, and that's been suppressed. I mean, every time somebody like Tesla comes along and starts to expose it, it gets shut down.
Tesla comes along to expose what now?
To expose that there's
Tesla as in Tesla the guy, not Tesla the company. I was thinking like
Elon Musk did what? Did nothing. Yeah.
Gotcha.
No. I didn't catch the second part of it, but yeah, don't know.
All right. Samir, thank you for the super chat. TJump, please help. Which statement is true or worse? There are flat earthers. There are dummies like me who believe there are really flat earthers.
Yeah, how would you answer that one?
I think they're like the same statement. So if there are flat earthers and Samir is a dummy who believes there are flat earthers, those would be the same, right? Because if there are flat earthers, it's rational to believe there are flat earthers. So seems like they'd both be true.
I'm one. Hello.
Super chat from Anthony Sorellis. Dave, what are your thoughts on the next eclipse in the USA?
Okay, well, so somebody's been watching one of my videos, it looks like. Yeah, there's an eclipse coming on 2024, which is 7 years on from the last eclipse that went across America. Personally, I believe that that's a sign, and it's a sign of impending doom for America.
Why is that a sign of impending doom?
Okay, I sort of put a lot of faith in the Old Testament, and the Old Testament basically says that sun, moon, and stars were given for signs and seasons. And we all know what the seasons are, but the signs, well, a big sign in the sky would be an eclipse, and usually, maybe 500,000 years ago, you saw an eclipse, you'd run for the hills because it was a sign of impending doom. Now, America got one eclipse in August 21st, 2017. It went across America one way, and you're getting one again in 2024. It goes across America the other way, forming an X. And it's too long to go into, but I think that's a warning. And sometime after that, I think there'll be some catastrophic event that befalls America. That's my view, anyway.
Gotcha. The nihilist says that's like taking on an evolution challenge governed by Kent Hovind. He's going to the gambling thing. Would you bet on an experiment designed by somebody else? Like, obviously, I wouldn't place money on an experiment designed by Kent Hovind to disprove evolution or something for the same reason, like the magician kind of a thing. So I think it's in the case you gave, it was rational for the scientist to not want to put money on that, even if he didn't explain
Sure.
why.
Yeah, but you know what? If he'd explained it like you did, right, I would have said, yeah, good point. You know what? Why don't you put the experiment together, right, so that you know that there's no funny business there.
Gotcha.
I'm not trying to skew any results. I'd like to know, what the truth is either way. I mean, I'm not saying that, even though I absolutely believe the Earth is flat, right? I'm not saying that I'm 100% certain. I know 100%, couldn't be swayed, right? This experiment would have been the thing that, if it came out to be a ball Earth, I would have to say, okay, I'm going to have to rethink my ideas.
Gotcha. Samir asked, TJump, I meant if they fake it and I believe them. So I think his question is the Poe question. Is it rational to believe flat earthers genuinely believe that the world is flat, or if they're posed, that kind of thing? I think you could genuinely believe it. I genuinely believe that flat
Yes,
earthers actually believe what they say.
absolutely. I mean, look, I was brought up with the same model as you were, yeah, and I was a fan of science. I was a huge fan of science fiction. I believed all that stuff, and it took me about a year of looking and feverishly looking at stuff and researching and doing experiments. I mean, 24 hours a day before I said, yeah, I'm a flat earther.
Gotcha. TJump, the inconsistent angles of the relationship between the Earth and Sun prove. Oh, it's the same thing.
It's the same one you
before.
Yeah.
Why Gyara GG asks, why do flat earthers always have to believe other conspiracies as well?
It's not, again, flat earth is not a conspiracy, right? Not a conspiracy theory. Yeah. It's when you start looking at things, when you start actually asking questions, right, then you're going to start finding answers, and you're going to find answers that don't make sense according to the official narrative. And that's massively true when it comes to the flat earth. But then when you're not looking at the flat earth and you see something in the real world that says, COVID is real, and you start looking into that, asking the questions, or the rational questions, and finding out that the establishment aren't asking those questions and are actively censoring you for asking those questions. Yes, you start to see things differently.
Gotcha. Average Joe 11, thank you for the super chat. Can Dave use his model to predict a single eclipse? Why is he seeing results from the globe model if it doesn't work?
You don't need either model to predict an eclipse. What's the guy's name? Benjamin Banneker, I believe it was. Made a wooden clock. Yeah, he was predicting eclipses. He wrote an almanac or something that predicted eclipses. Before knowing about either model.
Gotcha. Next question is from Jasmine Griffs. What would the benefits be for all science convincing everyone that the world is round and if it's actually flat? Like you mentioned that.
It's the same.
Well, I think you're asking more specifically, like you said, it's to weaken our minds or something. Like what specifically are they trying to achieve by weakening our minds?
The only way you can control, right, a small group of people can control 7 billion people, is to psychologically weaken them. Okay, if you knew that this is the universe, right, and you were, this is a created place, you wanted a chief of the creations here, you'd start to realize that you have a purpose, right? That every life is sacred. You've got a purpose here, and nobody can stand above you. Only the Most High is above you. Okay, if you knew that, then you could not be controlled. But if you believe that you are a tiny microbe on a speck of dust in an infinite universe that got created by accident from an explosion, and your life doesn't matter. There is no control, nothing in control of this universe, right? You've got no purpose. Then somebody who's more powerful than you on this earth can start giving you orders, can start telling you what your purpose is. And according to them, our purpose is to get good grades at school, get a good job, make lots of money, buy lots of crap, buy more faster and expensive crap, and then die. Okay? No, that's the purpose they've given us, and that isn't the purpose we're here for. But if you weaken people's minds, you can get them to believe that.
Vlad asked, who is the Most High? You said you were not religious. I think by religious, he meant like religious institutions. He does believe in a God. Do you have a specific, like which God or something?
Well, there is only one, and he would be the one that's in the Old Testament.
Gotcha. Perfect One asks, people get the impression that you cannot listen to an explanation that contradicts what you embrace, talking over and shutting down. Why do you think that is? I haven't gotten that. He's listened to pretty much everything I've said. He hasn't really interrupted more than anybody normally does. So I have not gotten the impression that he can't listen. So I wouldn't say that. But did you want to respond to that?
No, I don't think I do that, to be honest.
Gotcha. Pineapple Jesus, how thick is the earth? Does size matter?
Yeah, size doesn't matter to me, but no, I've already said that. Again, it's not a question of how thick the earth is. It's that there is nothing beyond it. Just like, we don't know what's on the other side of the universe. Yeah, it's the same model, just smaller.
Gotcha. Pragmatic Crystal asks, why is it hotter at the equator?
Because the sun spends on average, more time over the equator. Yeah, it hovers between the two tropics. So on average, it's going to be hotter in the middle.
Gotcha. If the Bible is correct, the lesser light rule over the night, then how come we sometimes can see the moon during the daytime?
Okay. Well, again, I'm not the Most High. Yeah, it rules over the night, but it's not always there. So I don't know. It's also part of a clock. Yeah, so we're supposed to be able to know what month it is because of the moon, because where it is in its cycle.
Gotcha. What does Dave think about dinosaurs from Foxtrot Red?
I have no regard for dinosaurs. I know there's people looking at them and stuff, but I'm not really interested, to be honest.
Gotcha. Elliot Leisure asks, is there any kind of experiment that would convince you that the Earth isn't flat? I remember a guy who built a rocket so he could find out for himself. For example, the guy who, remember that story?
Yeah, he wasn't a flat earther. I met the guy, Mike something, and he actually died. I met him in Denver, and he's not a flat earther. He just wanted to build a rocket. So he didn't build a rocket to test for himself. He just wanted to build a rocket. No, I at this point, I don't know of any test apart from the experiment I was going to do, and I still might do. That would convince me. I'm not going to say what the experiment is because I don't want somebody to preempt me and falsify it like you were saying.
Gotcha. I think that's it for the questions. We've been going for about 2.5 hours. Really appreciate you coming on. It was a great conversation. Do you want to give any links or references where people can find out more about your work? Again, I'm not really focused on flat earth all the time, but my website is allegedlydave.com, and
gotcha. I think my YouTube channel is dmurphy25, and you'll find some stuff on there.
Awesome. Thanks again. Really appreciate it, and I hope you have a wonderful rest of your day.
Yeah, you too. Take care.
Oh, we just got one super chat in just in time, which I should probably read because it's They're paying me. Which is bigger, the flat Earth, or the universe above it, or are they one on top of the other and both infinitely big, like a infinite pot in its lid?
Okay, my view of the Earth is a bit different to a lot of flat earthers. So, if you imagine a large frozen lake, okay, a large roughly circular frozen lake, and above one corner, so 1/4 of that lake, there's a heat source, the sun, going round, melting out a puddle on that lake. Okay, so that puddle is our Earth. It's melted out of this larger lake. Okay, and the edge of that puddle is what we call Antarctica. So it's the ice that hasn't been melted. That heat source, the sun, is going around a magnetic center, which itself is moving around the rest of the lake, taking the sun with it. So as the sun moves with this magnetic center, it's melting out a different part of the lake. Okay, and I think according to some people, I think it's actually a lot faster, but we move something like 1/12 of the circumference of the large lake every 2,160 years. I think it's a lot quicker than that, but yeah. It's from a guy called Iwar Anon, who did a set of videos a little while back. So I think there's a larger Earth, and that's what the dome is over, and our Earth is just the puddle that just happens to be melted out at this moment.
I think he's asking specifically, like, could the dome be infinitely flat above us and the Earth is infinitely flat below us? And is that like a possible version of the flat Earth, or does the dome have to like have an edge somewhere that we can hit?
I think personally, I think there is an edge that you hit, but there are people who believe in the infinite plane. That I don't subscribe to. There is another model I've been kicking around, but it would take too long to explain. But it involved. I can't really go into it, to be honest. Too involved. But yeah, there's people who believe it's an infinite plane, and those people don't believe in a dome. But I actually believe that there is a finite limit to the Earth. But our Earth is just one part of a larger Earth that gets revealed as the sun actually moves around. I don't know if you've seen the Prague astronomical clock.
A while ago, yes.
Right. If you look at that clock, you'll see it's literally that model that I've just described. There's a circular bit that actually moves around the whole face of the larger clock, and around that that small clock, the hands have the sun and moon on them. So it's literally modeling the Earth that I just tried to describe to you.
Gotcha. Well, that is it for the super chats. Thanks again for coming on. Really appreciate it. And I hope you have a wonderful rest of your day.
Okay, you take care.
Talk to you later.